In this tutorial, I aim to guide you through all the necessary steps to build a web service in Studio Azure ML. First of all, you need to go to this following link, then sign in. You can use plenty of options to pick an account to sign up. I recommend using GitHub credentials. When we get here, you can simply ignore the message that pop up. You can choose, you need to select a new experiment, blank experiment. We will wait till the workspace is loaded. This message you can ignore it simply because it reminds us that the support for Machine Learning Studio will be retired on 31 August 2024. Once here, may begin by naming the experiment. In this case is an iris binary classifier. Then we hover over the left panel. We begin by loading the iris dataset. Simply drag the data and drop it in this region. If you want to check the data, click menu context, open the menu context and click on visualize dataset. You will get 5 columns. The first one is the class, the target output, and the 4 remaining columns are the features. We need to, given the length and width of sepal and petal, width and length of the sepal and petal of a flower, of given flower, we need to classify it. Some statistic can be found in the right region. You can also compare, for instance, the sepal length to the class. You can check that there is some correlation between sepal length and class. Class, it depends on the values in sepal length. However, we can make sure that sepal length is not does not depend on petal length. Later on, we need to load the machine learning algorithm. It's a classification problem, so we can choose the very basic one we saw together, which is a 2-class logistic regression. We will train it using the data we loaded. So we simply drag the train model module. We connect the classifier to the train model. The data also has to be connected to train model also. Train model, we feed the data iris 2-class data to the logistic regression. Once done, we score the results given the same data set. Later on, I'm going to split the data into 2 sets, training and the test, the unseen data, to score some metrics. Finally, at last, we evaluate the model. The evaluation consists on building, in this case, the confusion matrix, compute the accuracy, precision, recall, and F1 score of the algorithm. If you find a red exclamation mark, it means that something is missing. In this case, we miss the target or label column, simply click on train model and launch the column selector. I need to explicitly tell it that the class, the column labeled class, is the target, is the outcome or the target for me. If everything works fine, I run the experiment. All the check marks are green, so the experiment has been run successfully. If you however evaluate model and view the evaluation results, we will get the confusion metrics, the accuracy and precision, recall and F1 score. These results are a little bit biased, let's say, because we have fed the algorithms with the same data we use it to score it. That's why we need to split the data into two sets, test and train. For this reason, we go to data transformation on the left. We select split and sample and split, and we choose the option or the function split the data. Split the data, we will get two output: result data set 1, we feed it to train module, and result number 2, we feed it to score model. However, we need to tell it the percentage of sampling or partition. In this case, I will put 0.8, meaning that 80% of the data will be loaded to the first data set and the remaining 20% for the score model. It's preferable also to stratify the split, meaning that we get the same partition of 0 and 1 classes in the train and the test set. Yep, the column to stratify, it's also class. We run the experiment. All check marks are in green, meaning that the experiment has run successfully. Now we need to set up a web service. And we need to deploy it. Before deploying, it's by obligation to run the experiment. And then deploy it. Here you will get the API key to the web service. If you want to test it, you may simply click on this link. We will feed some data to the algorithm and we will check the results. For instance, let me say I can ignore the class. Let me say sepal length is equal to 5.3, sepal width 2.8, petal length is 3.2, and width is about 1.4. Test the request response. We get some scored probability of 0.53, which is above the threshold in logistic regression 0.5. So at last the scored label is 1. If I need to integrate this test into some Python code, you can simply go to the request response web page. you will get snippet of code you can use to build your algorithm. You can run your algorithm from the desktop. Click on Python anglet and then copy and paste the code. Keep in mind, please, to change some names if you are using Python 3. It's recommended to load the library URL lib. You simply can omit the two. For the VS Code, you will get at last some code here when you specify the API key and the HTTP to run your web service. For this case, for instance, I'm doing a test with some values, some features as indicated in this row. The result normally would be 1. The second test, the result normally the class has to be 0. If I run the test, for the first simulation, the scored probability is 0.79, which is assumed to be 1. As for the second simulation, is 0.13. It's below the threshold. The algorithm has scored it as said that these features belong to the class 0. This code, you can find it on my GitHub repo, co snip Python. Thank you.